Welcome, students. This is the lesson for Monday, January 13th. We're continuing our study of systems of equations. Last class period we learned that a system of equations was two or more equations. So it's just two or more equations. And we learned how to write those from a paragraph. So we'd read a paragraph and we would write the two systems of equations. For us in algebra, we just focus on two of them, but you'll learn later on when you get into Algebra 2 and above that there can be three or more equations as well. Today we're going to learn more specifically about finding the solutions to a system of equations. If you have two linear equations, that's going to be two lines on a graph. Okay, and when you put two lines on a graph, there's three things that can happen. The first thing that can happen is the lines can just cross, and where they hit, this is the solution. Okay, and that'll be an ordered pair in x, comma, y. The second thing that could happen is you could put them on the graph and they could be parallel lines, and this is considered no solution because there's no place where those guys hit. The third option that can happen is you could graph the line, and then the other line could be basically right on top of that line, and this is said to be infinite solutions, or basically every number that goes with x and y is a solution to this graph. Okay, so we have one solution, no solutions, and infinite solutions. Okay, and we'll focus on all of those as we go throughout the class period today. The method that we're going to use today is called substitution. Solving by substitution. And it really involves a lot of the algebra skills that we learned back in the first semester. You're going to have to substitute things in, which substitute means you're going to take something out and put it in its place like we would do in basketball if our point guard was turning the ball over left and right, or if he got hurt, we would take him out and we would put somebody equal to him in his place. And so that's what we're going to do. We're going to take one equation, we're going to substitute it in to the other one, and then we'll have to solve it. We'll have to do some distributive property. We'll have to do opposite subtract. We'll have to do a lot of the things that we learned back in the first semester. Here are the steps that we're going to do. Step 1 is solve one of the equations for either x or y. And so you're going to have to figure out which one is an easier one to solve. Some of them are easier, some of them are not. Here's a good hint. It says look for variables that have a coefficient of 1. So an example of that would be if I were looking at x plus 2y equals 13, x has a coefficient of 1, so it's easier to solve for x than it would be for y. Y would be more complicated, and it would produce some fractions possibly that would make the problem even more difficult. Okay. Step 2, once you get it solved, you're going to substitute it into the other equation, and then you're going to solve. And this will be where a lot of our work is done. There's some special situations that happen here, and we'll discuss those as we get to them in the video here. The third step is once you get that solved, this is going to give you one of the two letters, either x or y. You're going to substitute it back in and to get the other solution. Okay, so you're going to find the second solution doing that. Okay, and a lot of that may not make a lot of sense just hearing it in words, but as we see the problems, you'll start to see what we're supposed to do. All right, the first problem we have here is y equals 3x minus 2 and y plus 4x equals negative 2. And so we look at the two equations and we're trying to find, is one already solved for us, or is there one that's easier to solve than the other? And we got lucky here because this one already up here is already solved for y. So that right there is what y equals already. So we're going to take this y out, and we're basically going to swap circles here. This y is going to come out, 3x minus 2 is going to go in its place, and then we'll solve the problem from there. And so we'll rewrite it as 3x minus 2, and then all we did was replace that circle, the y. Everything else we just rewrite as it was. So that still says plus 4x equals negative 2. And now we're going to solve this equation, and when we get done, we'll have an x. We'll know what our x is. So back in the first semester, we learned if you have x's on the same side, you got to combine those. So we're going to combine 3x plus 4x. That's 7x minus 2 equals negative 2. Then we box our 7x. We get rid of that minus 2 by doing plus 2. Plus 2, we might even draw our line down. Those are all things we talked about in the first semester. Those cancel out. I get 7x equals negative 2 plus 2. It kind of cancels out, but it equals 0 when we do it. And then last step, when it's beside it, we divide it. So we divide both sides by 7. And 0 divided by 7 is 0. And this is the first half of my answer. And don't get scared away, because the first half is the most difficult work. The second part you're going to see is pretty easy to do. So then, once I have my answer, I have some options. I'm going to take this x equals 0, and I'm going to either put it right here, or I'm going to put it right here, whichever I think will be more easy. This one, because I've done a lot of these problems, I know that this one is going to be easier to plug it in and work with. So I take y equals 3, and I'm not going to put an x in there. I'm going to put parentheses 0, and then everything else goes like it was. So I kept the y, I kept the equal, I kept the 3, I kept the minus, I kept the 2. Okay? So 3 times 0 is 0, and 0 minus 2 is negative 2. And so this is the other part of my answer. So altogether, remember we talked about this has one solution. These hit each other. The point where they hit each other is 0, comma, negative 2. And that is our final answer for this problem. Okay. The second problem over here, we look at them, and we see that actually both of them have been solved. So we really could pick either one. I'm going to take this one because it looks more simple. And that's been solved for y. And so I'm going to swap circles again. So this will be 2x instead of y equals, and then this side just stays the same, negative 6x plus 4. So this one presents some different problems. We have x's on opposite sides, and so the rule in class we learned was you move the smaller one. So negative 6 is smaller, so we plus 6x to both sides. So that becomes 8x equals, those cancel, 4. When it's beside it, we divide it. So we divide both sides by 8. And we get x equals, that cancels. When I do 4 divided by 8, math 1 enter in my calculator, I find that it's 1/2. And that may scare you a little bit in the beginning because it's a fraction, but don't let it. Sometimes these are going to hit it at fractional parts. Then we take and we can plug it into the top or the bottom one. Knowing more about this, I'm going to plug it into the top one. I take out that x, and I put in that 1/2. So it's going to say y equals, instead of 2x, it's going to say 2 times 1/2. So here this is simple. I just take my calculator and do 2 times 1/2, and I get that it's 1. And so again, these are lines that hit each other, and they hit each other at the point x 1/2, comma, y 1. And continuing on, these get into the more complicated problems. When I look at the top one up here, 3x plus 2y equals negative 11, nothing is solved. X minus 4y equals 15, nothing is solved. And so now I'm going to have to solve one of these for a letter. When I look at this, this has a 3x here and a 2y there, and either one of those is going to be very easy to solve. If you go back to the little hint we gave you in the notes, this one right here is going to be the easiest one to solve for because the x has a 1 in front of it. So I'm going to pull that down here, x minus 4y equals 15, and I'm going to solve this thing for x. And I know we usually solve for y when we're solving these equations like this, but you need to be able to solve for both of them. So when we do that, we add 4y to both sides, add 4y to both sides, that cancels out, x equals, just like when we're solving for y, these cannot be combined, so this can be 15 plus 4y, or you could write it. We're not so much worried about an mx plus b form anymore because that's not what we're doing in this lesson. So you could do 4y plus 15 or 15 plus 4y. Now we got it solved. So this is going to replace x in this top equation up here. So I'm going to swap this circle in right there. And so this is what it'll look like. 3, I take out x, and in parentheses I put this whole thing, 15 plus 4y, and then I keep the rest of it. Plus 2y equals negative 11. So now I'm going to solve. So I got parentheses here, so I got to get rid of those. Double rainbow. 45 plus 3 times 4 is 12y. Keep going, bring down the rest of it. Combine my y's. So that's 45 plus 14y equals negative 11. Now I'm ready to solve for my y, so subtract 45 from both sides. That cancels out. I bring down my 14y. If you like your line, you can draw it down. Negative 11 and negative 45 is negative 56. And then last step, when it's beside it, I divide it. So I divide both sides, and I find out that y is equal to negative 56 divided by 14 is negative 4 in my calculator. And so that is my y answer. And so that was quite a bit of work for that one. That's a tough problem there. Okay, now I'm going to take it. The easiest place to plug it back into is the one you solved for. But you could plug it in for the top two. It's just more work. So I'm going to take out this y, and I'm going to put a negative 4 in there. So this is what it'll look like. X equals 15 plus 4 instead of y. It's 4 times negative 4. So that 4 times negative 4 becomes negative 16. And so I have x equals 15 minus 16, which is negative 1. So this again is one where they cross, and they cross at the point negative 1, negative 4. And so this is your final answer. And so that one was a tough problem to do, a lot of work to do for that problem. And we're going to learn some other methods over the next couple of days on solving these systems. And so this might not have been the best way to do this one, so we'll learn some other ways. Number 4 here, same type of thing as number 3. We have 2x minus 3y equals 7 and x plus 2y equals 7. We see that this one is the only one without a number beside it, so that's going to be our easiest one to solve. So x plus 2y equals 7. I'm going to solve for that, so subtract 2y to both sides, and I get x equals, that's just 7 minus 2y. So that's getting plugged in up here beside the 2x. Okay, so I'm going to bring that up there, right there, and put it there. So it'll be 2 times, instead of 7 minus 2y, instead of x, it'll be 7 minus 2y. Close my parentheses, and then I just bring down the rest of it. Negative 3y equals 7. Okay. I distribute, that's 14 minus 4y, bring down my minus 3y equals 7. Those get combined, so that's 14 minus 7y equals 7. Now I'm ready to solve this guy, so minus 14 from both sides, negative 7y equals 7 minus 14 is negative 7, divide by negative 7, divide by negative 7, and y equals positive 1. So that's part of my answer. Remember, I'm going to take that and plug it into the one that I've already solved for, so I'm going to take out that y and I'm going to put 1 in its place. So this will be x equals 7 minus 2 times 1. 2 times 1 is 2. So this is just 7 minus 2, or 5. So there's the other part of the answer. These hit each other in one spot, and we know that based on the answers that we got, and they hit each other at 5, 1. Okay. Number 5 and 6, we see that this one is already solved for, so that makes it a little bit easier. So we're going to take that and put it right there. We're going to swap circles again like we were doing in the beginning. 2x plus 10, and just bring down the minus 2x, and the equals 10. I go to combine like terms here. 2x minus 2x, and that actually goes away and becomes 0 plus 10 equals 10. 0 plus 10 is 10. And so I get this statement right here, which is 10 equals 10. My letters all went away. So that means something weird has happened. Okay, and we think back to that first slide that I talked about. We could have this happen, we could have this happen, or we could have them on top of each other. Okay? If we get a true statement, which is 10 equals 10, then this is what happened. The lines are on top of each other, and this is called infinite solutions. It doesn't happen a lot in our problems, but it will happen from time to time. The variable will go away and the statement will be true. Okay? This one, same type of problem. We can replace right there. So this becomes 2x plus 4, and I bring down the minus 2x, and the equals 10. 2x minus 2x is 0 plus 4 equals 10. 0 plus 4 is 4, and 4 does not equal 10. So the same type of thing happened, except it produced a false answer. A false answer means that there are no solutions that are going to work. So these would be parallel lines if we were going to graph them. Okay. On to the word problems. This you have to do what we learned the previous class period plus what we learned today. So you have to write the equation and then be able to go ahead and solve it. Our first equation comes from right here. It says the length is, so that's L is 4 greater, remember that is plus 4, and 3 widths. So 3 widths plus 4. The perimeter is 72. Remember we used 2L plus 2W for our perimeter. So this is 2L plus 2W equals 72. So we look at our two equations. This one is already solved for L. So we'll take out that L and we'll put that in its place. 2 parentheses 3W plus 4. Bring down the rest of it. Distribute, that's 6W plus 8. Bring down 2W, bring down 72. 6W, 2W is 8W, plus 8 equals 72. Subtract 8 from both sides. 8W equals 64. When it's beside it, we divide it. So we divide both sides by 8, and we get W equals 8. Uh-oh. She asked for what is the length. We just found the width. Well, that was the easy way to start out. But we are going to have to plug it back in right there and be able to find it. So we're going to replace this circle with 8. So length is 3 times 8 plus 4, or 24 plus 4, or 28 was actually the answer we were looking for. Okay? So the plugging in part, that part is usually pretty short, but we just find whichever one is easier to get started with. Okay. The sum of two numbers, so we're going to call our two numbers x and y, so the sum of those two numbers is 26, and their difference is 20. So those are our two equations, x plus y equals 26, and x minus y equals 20. Neither one of those is solved for us. They all are pretty easy to solve for. I probably wouldn't solve for y in the second one because that's a negative one there. I would probably just take this one, draw my line down, and do plus y to both sides. And this gives me 20 plus y, and I'm going to replace that into there. So this will be 20 plus y, and then just bring down the rest of it. Plus y equals 26. Y and y is 2y. Bring down the rest of it. Minus 20 to both sides. 2y equals 6. When it's beside it, I divide it. And so I get that y equals 3. So my first number is 3. Then I'm going to plug it back in. I can plug it in anywhere I want. I'll just plug it in right there. X minus 3 equals 20. Oh, no, that's not what I said. I told you in the other part of the notes to just plug it in right here. I think that's the better idea. I would not do that. So this becomes x equals 20 plus, instead of y, we put 3. And that becomes 23. So our two numbers are 23 and 3. If you add them, you get 26. If you subtract them, you get 20. Last problem here, we have Rachel and Caleb. I'm going to call Rachel x and Caleb y. Their difference is 12, so if we subtract them, we will get 12. Their sum is 50, so this ends up being a very similar problem to the one we just did. I think I'll go ahead and solve that top one again, and I'm going to solve it for x, because when I do that, it creates positives everywhere, and I like positives because I'm a positive person. So I get x equals 12 plus y, and I'm going to take that, and I'm going to plug it in right there. So I'm going to swap circles there. So this will be 12 plus y, because I already had a plus y, equals 50. That's 12 plus 2y equals 50. Minus 12, 2y equals 38. When it's beside it, I divide it, and y equals 19. So one of the people are 19. Plug it back in. One of the people being Caleb. Plug it back in, so I get 12 plus 19 is 31, and so Rachel is 31. It's a true statement. Rachel is older than Caleb, and so this is Rachel, and this is Caleb. Okay. I know these problems were pretty difficult, and we'll spend a lot of time in class practicing this type of thing. It requires you to really understand a lot of the stuff we did back in the first semester.